All righty, let's take a look at some of this voltage and electric potential stuff. So just as a little recap for what we've done so far, we've talked about electric force, or forces between electric charges, and that's called Coulomb's law. The units we used there was newtons because it's a force. And the equation we have to play with is F sub Q is K, Q1, Q2 over R squared. And I'm certain everybody remembers having done that before, or at least I really hope you do. Then we talked about electric fields, and that is the units are newtons per coulomb. So it's a force per unit charge. And the equation we used for that, for the most part, was E equals KQ over R squared. Sometimes we also had F equals EQ for some of the things we were doing if we had like electric field between plates. So electric charges exert a force on each other. Electric charges produce an electric field, and E field between charge plates is constant, while the E field from a point charge is variable. In other words, it changes with 1 over R squared. So that's the difference between these two E field equations. But the point is that each of these are capable of expressing electric field, and electric fields are capable of creating forces on particles. So what if we talk about moving a charge through an electric field? Like in our last worksheet. And so what this is actually referencing the very first worksheet that I'm putting up on Canvas for this stuff. And I would recommend that you do that worksheet before you look any further on the notes. So if you haven't done that worksheet yet, just take a minute and press pause or whatever on this and go back and try that worksheet, because the whole point of that worksheet is to try to emphasize the idea that you really understand the idea of energy in electric fields, which is essential for voltage. And it's just actually me trying to help you reference that knowledge in your mind before we start talking about something new. It always helps when you're learning something new to be able to compare it against something that you already know. And so that's what I'm trying to do on that worksheet. So you could actually do that worksheet before you do any notes at all. But either way, moving on. What if we move a charge through an electric field? Well, then we would be exerting a force against the electric field and moving the charge some distance. In other words, if you're exerting a force over a distance, then you know that work is being done. And in this case, work is being done against the electric field. And so if you understand that moving a mass against a gravitational field takes work, then you understand that moving a charge against an electric field also takes work. It's the exact same concept, where it's just depending on whether you're moving a mass through a gravitational field or a charge through an electric field. And work and energy are the exact same quantity. This is why we often talk about a mass in a gravitational field having gravitational potential energy. And similarly, we can talk about a charge in an electric field having electric potential energy, which is what we're about to do. So if we talk about having our little teeny tiny positive test charge, and here is a point charge here, we talk about moving this test charge in, it would be harder and harder and harder to push it this way. And it would want to shoot off that way because that's the direction of the electric field, right? Electric field is the direction that a teeny tiny positive test charge would go. And if we look at this position here we have two plates. Here is the positive plate, here is the negative plate. So the electric field here would be directed downward because, again, the direction of the electric field is the direction that a teeny tiny positive test charge would go. And so looking at this, we talk about here, we'd have the electric charge would be pushed downward in this direction. The difference between these two pictures here and here would be what's happening to the electric field as we're moving. In here, the electric field is constant the entire time, and here, for the point charge, the electric field gets stronger and stronger and stronger as we get closer and closer to the point charge. So these two situations are similar in the fact that we still do work against a field to move a test charge against them. Similarly, here we would do work to move a test charge against the field here. But the difference between these two is that here the field is considered to be constant, and then here the field is changing. It's increasing as we get stronger and stronger and stronger. And we'll talk more about that in just a minute.